Hello everyone, and welcome to this example recording on the step response of an RL circuit. So the question we're going to be attempting reads as follows. Determine V0 for t greater than 0, and V0 is the voltage over the inductor. So we know that ideally the inductor is associated with current, and the equation would go as follows. The current flowing through the inductor is I infinity plus I0 minus I infinity e to the negative t over tau. So how would we then get V0? V0 must be the derivative of that current, because we know that V is L di dt. So it will just be the derivative of the current expression multiplied by the inductance. Now that we know that, we need to then determine the initial, final values and the time constant. Let's start with the initial value, time t equals to 0 negative. Right, so at time t is equals to 0 negative, we know that we're going to have our 40 volt source, the 10 ohm resistor, the 11 ohm circuit, and the 7 ohm circuit. Resistor 7 ohms, 11 ohms, the inductor is replaced with a short circuit, and then you've got your 10 ohms and 40 volts. And the current I0 must give us the total voltage, which is 40, over the sum of the resistances, which is 10 plus 7 plus 11, which is going to give me 40 over 28. Which is 1.43. Right, and that's the initial current. What about the final current? So the current at time t, or rather at t tends to infinity, what will happen? So we know that the voltage source 20 volts will now be part of the circuit. So we will have the voltage source connected to the 10 ohm resistor. We will have the 20 volt source connected to the 5 ohm resistor, and then we're going to have the 7 ohm, the inductor, which is a short circuit, and the 11 ohm connected resistor. And we are looking for the current I0, which would be the same as the current I at time t is equals to infinity. So there are many ways that we can solve this. One of them would be to determine the voltage at that point, and we would use KCL to determine that voltage, and then we divide that voltage by 11 plus 7, which is the total current in that branch, to determine the current I0. Another approach which we can take is to use the principle of superposition, which states that a voltage source in series with a resistor between points A and B can be changed to a current source in parallel with that resistor between the very same point A and B. So using this principle, we can then simplify the circuit. So we're going to say the 40 and the 10 is going to give us a current source and a resistor. Current source value 40 divided by 10, which is going to be 4 amps with the 10 ohms, and the second voltage source will also become a current source with a resistor in parallel. Value 20 divided by 5, which is 4 amps and 5 ohms. and that will connect to this branch, which is 11 plus 7, which should give you 18 ohms. And that will be your current I0 that we're looking for. Now we can simplify this. 4 and 4 will be 8. 10 in parallel with 5 will give you 3.33 ohms. And we have our 18 ohms with I0 that we're looking for. Now we can determine I0 by using current division. So we'll say I0 is 3.33 over 18 plus 3.33, all multiplied by 8 amps. So I0 should give you a value of 3.33 over 3.33 plus 18, which is 11 plus 7, multiplied by 8. That gives us a value of 1.248 amps. Alright, then we need to determine tau, which is L over R. L equivalent we know is equals to 20 henries. What about RTH? So if we look at this circuit, which simplifies to this circuit, we can now determine RTH. So we can say that the current source we know is going to become an open circuit. The equivalent resistance will remain 3.33, and with the 18, and then we can, just for clarity's sake, we leave that as an open circuit so that we can see R equivalent. So R equivalent must be 18 plus 3.33, which is going to give you 21.33 ohms. It's important to note that you could have done this from any of these circuits. You could have done it from that circuit here. So you could have said this becomes a short circuit, 10 in parallel with 5 gives you 3.3, plus 7 will give you 10.33, plus 11 gives you 21.33. And then we determine the time constant, which is equals to L over R, which is going to be 20 divided by 21.33. Which gives us a value of 0.937. seconds. To then give us a final expression of I as a function of time is going to give you the current I infinity, which is 1.24, plus the initial current, which we calculated to be 1.43, minus 1.24, e to the negative t over 0.937. This is going to give us 1.24 plus 1.43 minus 1.24, which gives us 0.19. e to the negative t over 0.937 amps. And then to get the voltage, we said the voltage VO must give you L di dt. So that will be 20 times the derivative d dt of 1.24 plus 0.19 e to the negative t over 0.937. and this is going to give us 20 multiplied by derivative of a constant is 0, so 20 times 0.19 multiplied by 1 over, or rather minus 1 over 0.937 e to the negative t over 0.937. That's going to give us 20 multiplied by negative 0.19 over 0.937. And that gives us a value of negative 4,055. So this is going to give us negative 4,055 e to the negative t over 0.937, and this will be in volts. And this is the value of V0. Thank you for watching this video and enjoy the course.